You may have heard of ChatGPT or GitHub Copilot, but what are they and how do they work? Both ChatGPT and GitHub Copilot are large language models, or LLMs for short. LLMs are text-only machine learning systems which take an input piece of text and respond either as a chat model or a completion model. What is great about these systems is they are able to generalize and can change how they react based on the input instruction. Notice I said text-only models, but some of you who have used GPT-4 or other advanced LLMs may know that they accept images and videos as well. These systems are called Multimodal LLMs, which are language models which can use another form of input besides text. Today, I will demonstrate how multimodal large language models work and why they are so important to the future of AI. To understand multimodal large language models, you must first understand normal large language models. Large language models are composed of two parts, a tokenizer and a transformer. Let's first focus on the tokenizer. The tokenizer takes in an input string and outputs a set of numbers related to that string. It does this by learning from its training data how it should split strings into tokens, small fragments of words and sentences, sometimes just letters or punctuation, sometimes more than that. And then it takes those tokens and assigns them unique numbers. We need to change strings into a series of numbers because machine learning systems are just complex mathematical functions, and they only work with numbers. Next, let us talk about the transformer. A transformer is composed of several attention layers. An attention layer is a machine learning layer, which determines how important each token of the input to it is. It utilizes that information to generate a new output string of tokens. Here's a sample visualization of an attention layer from StarCoder, a code LLM. As we can see, the model considers different parts of this input to be more or less important. It pays more attention to the parts with high importance, and they have a bigger effect on the output. An attention layer takes input tokens and turns them into a series of embeddings in an n-dimensional real space. This is a bit hard to visualize, but imagine we're embedding 4 words into 2D space. Say the words are king, queen, boy, and girl. We would want the embedding in such a way that king minus boy plus girl might give us queen. So the embedding acts as a way for a model to visualize the association between words, or in this case tokens, which it wouldn't have otherwise understood just from straightforward numbers. The embeddings are passed into a neural network, which produces the set of next tokens for the next attention layer. I am oversimplifying a bit, so if you're interested, I would recommend you look further into this on your own time. Now that we know how a transformer operates, we can add additional modalities. To make an LLM a multimodal LLM, we need to add a new model that can process the new modality. In this example, I will be talking about images and using this image of a lasagna. For images, we need some sort of vision model, maybe a convolutional neural network or a vision transformer. The actual model will change based on the modality, but we still need some way to connect the output of the visual model to the transformer of the LLM. We use a connector network to link the output of the vision model with the transformer. This connector network can be as simple as a linear map to a collection of cross-attention layers. With this now in place, we can input to our multimodal model both a string and a picture. For example, the string, "What is this?" and our image of a lasagna will be input into this model. The model will know that we are referring to the image and that the image shows a lasagna. and so it will respond with lasagna. So we have created an LLM with an additional image modality, which it uses to formulate its responses. So, you now know how to make multimodal large language models, but why should you make them? With original large language models, you're limited to text input and text output. This is great. A ton of tasks can be done using just text. For example, writing a story, completing some code, or answering your questions. However, a multimodal LLM can do everything an LLM can do, such as answering questions and writing a story. But it can do more. It can answer questions related to images, it can understand and describe diagrams, and it can plan paths through space. These multimodal systems are able to complete tasks beyond what a normal LLM could ever hope to do. For example, I want to show off Google's multimodal large language model, Manim, which is able to control a robot. Here's a video of it trying to grab a bag of chips. As you see, it can navigate through the world, open the drawer, and grab the chip bag. And when there are issues, it updates itself. Similarly, here's another example of Palmy sorting objects. It's tasked with moving red objects to the coffee cup. As you can see, it is able to move them to the cup, and when the cup is moved, after a couple of seconds, it is able to write new instructions and correct itself to move the red objects to the coffee cup once again. Additionally, here's a sample of Palmy doing visual question answering. I showed an image of some basketball players and asked them who they are and some information about them, and is able to respond. Machine learning models could do this in the past, but they would only be able to complete one of these tasks. On the other hand, Palmy is able to do all of these tasks without needing to be retrained. The ability to handle multiple tasks at the same time is what separates multimodal large language models from previous generations of machine learning models. They can generalize to new and unseen tasks without needing additional training. That means training cost is limited to only the initial training and the training to utilize any new modality. We can use a single model to cover a large range of tasks and even work on new tasks. A training dataset can't cover every possible use case of a model, so to have a model that can adapt to new situations means that it can handle any arbitrary task you throw at it. AI was created to match human capability while remaining completely automated. However, there was a big issue with artificial intelligence in comparison with human intelligence. Human intelligence is general, able to cover a wide range of topics at once, is adaptable to new situations, is able to learn new tasks relatively quickly, with basic instructions or an example. Additionally, humans are able to make use of all of their senses when determining the best course of action. Before multimodal language models, AI was built for specific purposes, could really only handle one task and one straightforward set of inputs. However, we have seen multimodal language models can generalize to a variety of topics. They can adapt to new tasks given new instructions or examples, and they are able to utilize a variety of inputs when making their decisions. Multimodal language models are so significant to AI as they are our current closest approximation of human intelligence.